Hello and welcome to today's video. So I've gone ahead and did some more modifications on this power supply. I've bolted in the two relays on this side, and of course there's two more back there on the other side of the transformer. And the way I wired these guys up is the common goes over to the actual post, and the normally open connection goes over the PCB. If you watched the last video, I showed how I isolated the post from the PCB, so go watch that. But that means that the normally closed terminal is available for anything I want. So when the relay is not energized, that's connected. So I might make that a load, or a resistive load, or another supply. I don't know. Future option. We'll see what I want to do with that. Maybe I have I don't know, come up with something. The other modification I did is I've soldered a bunch of wires onto the AC. This is out of the transformer on the black, blue, and white taps off the transformer there, and that goes over to this connector. And what I'm doing with that is I went bridge rectified and put it on the capacitor, and did a little testing and found that the 10 volts across the blue and the black will power my microcontroller fine, because it has an onboard 3.3 volt regulator. And between the blue and white lines, I get 21.5 volts, which is enough to run my 24 volt relays. And so that's what I ended up doing. Across the white and the black, I ended up with 31.5, which is way too much. So I made the blue my common ground. And then I went ahead, and the white wire goes through a diode, and that does a half wave rectification on 470 microfarad 35 volt capacitor to get my 21.5 volts to power all of the relays. And the same on the other side, I got another diode. It's like they're both identical. It's a 1N4004, which is a 400 volt 1 amp diode, but it's going to be plenty, a little overkill voltage wise anyway. And that gets me my 10 volts to run my micro, and that's filtered with a 680 microfarad 25 volt cap. And these are really big just because we're only doing half wave rectification. And then to drive the relays, I've got the microcontroller set a pin high and low, which is 3.3 volts, through a 100 ohm resistor, and that's the LED that's in an optocoupler, and that turns on this NPN transistor. And I got 21 volts coming from here, 21.5 volts, and it goes through the relay to turn it on. And then there's another 1N4004 diode. When this shuts off, that shorts out the inductive kick that could damage it. So got those on there, and so there's 4 of these circuits. And then down here I've got the 4 indicator lights on the front there. I've just got micro pin going through a 220 ohm resistor, turning on the LED. And that 220 ohm resistor was chosen just because I happen to have a bunch of them, and that got me pretty close to the same brightness as the other LEDs on the front panel, so I wanted to be close. I can always PWM this to get that a little dimmer. It is a little bit bright. And then the switches are 3.3 volts on the micro, and we got a 10K pull-up, and then the actual switch itself. So they're just momentary push buttons, and there's 5 of these circuits, 4 of these circuits, and 4 of those circuits. And that leads us to this guy. So this is the power supply section. You can see the little diodes are in there for my half-wave bridge rectification, or half-wave rectification, not bridge. This is my processor board here. It's got an onboard 3.3 volts, and then I'm just using the 4 outputs on each one. So there's 8 outputs. These 4 up here run the LEDs, which will go to this connector here. Oh, no, actually these are gonna, these I'm gonna crimp a connector on that'll plug in here. This does the actual push buttons, so it reads all 5 push buttons that way. And then this other one, which has got less, you can see I've stripped off some of the wires to test for brightness, will go to this plug here. That'll run all the LEDs on the front panel. And then this group of 4 right here, I/O lines, run the optocouplers, which turn on the relays. And you can see the little diodes there, are the catch diodes. for the inductive kick, and power comes in here. So it's a nice little thing. The back is well, it's point-to-point soldered, so it's not that pretty, but it gets the job done. And it's gonna get mounted right here. So it's just gonna fit down in here like that, like so. So I just gotta find, I have some standoff somewhere, I hope, and we'll just mount it like that, and then that'll have I gotta build the cables to plug into the relays and crimp on the connectors to all the extra things, and that'll be it. That'll be done. So hopefully next video you see it running. Gotta write a little bit of code to read the inputs and turn on the outputs, and that's it. So anyways, thanks for watching.